Okay. All right. Hello, ladies and gentlemen. Today we are going to talk about in chapter 9.9, lesson 1, properties of radicals. So, this section is actually going to be like, 7 days long. It's the most ridiculous thing ever. So here we go. Now, if you look on the back of the cover page, I have this multiplication chart, and you might think, well, multiplication chart, that's for like fourth graders. But no, for real, you are going to want to fill this in, okay? And when you fill it in, I would recommend highlighting the diagonal. And yes, I messed this up, but fill it in correctly. So pause the video, fill it in correctly. I would fill it in by yourself, okay? Use your brain. But definitely highlight that diagonal that I showed you, because this diagonal that you're going to highlight is going to be your perfect squares. So along this diagonal, those are your perfect squares. So 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on. So like 4 squared is 16, okay? So 5 squared is 25, 6 squared is 36, and so on. So if you think about this, 6 times 6 is 36. So that's it. Fits the square. Notice how this is a square. Does that make sense? Hopefully it does. Anyways, so this way I can also show you that the square root of 36 is then 6, right? The square root of 25 is 5, and so on. The square root of 100 is 10, right? You get the idea, right? Anyways, so this entire chapter is about square roots, also known as radicals. So a radical is a square root, right? A radical expression is any expression with containing a square root. So with no equal sign, okay? Now the next question says, what is the difference between the square root of 4 and the square root of 12? So what is the square root of 4? Hopefully you said 2. And the square root of 12, well, it's a decimal, right? The square root of 12 is not a perfect square. 12 is not on my diagonal. So that's the difference. The square root of 4 is what we call a perfect square. And the square root of 12, so there you go. The square root of 4 is a perfect square, which means like the square root of 4 equals 2. Okay? Now, what I want you to do is we're going to do a little calculator work. So hopefully you have a calculator. If you don't, use your phone. Oh, there you go. And hopefully you can figure out how to use your phone, the square root, turn it sideways, right? Okay. Anyways, now this is what I'm going to have you do. Square root of 12 on your calculator, and you're going to want to learn this using the calculator. So you're going to push the second, right? Notice when I push the second button, it shows up on my screen, second. And the square root is this square button right here, and above it has that little square root symbol. So you push that and it pops up. 12, right? Close the parentheses and then hit enter. Square root of 12 is 3.464. So I'm going to write that down. Square root of 12 is 3.464. So sorry. Okay. Now, you're going to go on to the next one, and I'm going to do the same thing. So it says 2 times the square root of 3. So 2, and then second, x squared, and then 3, close the parentheses, hit enter. 3.464. 3.464. Okay? Now I want you to pause the video and finish these up. I know you didn't pause the video, so keep pausing. And after you finish these, write in here a few noticings and wonderings. I will be looking for this, so please make sure you do that. What do you notice and what do you wonder about the answers here? Okay, so hopefully you may have noticed that all of these answers on the left were exactly the same answers on the right. However, square root of 32 is not the same as the 4 times the square root of 2. So you might wonder, how do we get from the square root of 4 to, from the square root of 32 to 4 times the square root of 2. So that might be something that you wonder, okay? Make sure you write that in your noticing and wondering. So the lesson for today is try to figure out how we move from one thing to another. Now, if I look at this, I'm looking at the square root of 45. The square root of 45 is comprised of two separate numbers, which is the square root of 9 times the square root of 5. So what we can actually do is separate those as two separate pieces, and then we get 3 times the square root of 5. So these two things are actually equal. The square root of 45 equals 3 times the square root of 5. Now let's kind of think about how that works. So what you're going to do is you're going to take the square root of 32 and you're going to look for the largest perfect square that divides equally into 32. Now you may notice, oh, this one is already done up here. So 4 times 2. So I already know the answer, but let's see how we actually get to the answer. So what is the largest perfect square? And this is where you go back to your diagonal. So I say, what is the largest one of these numbers that divides evenly into 32? Does 25 divide into 32? And the answer is no. Does 16 divide into 32? And you might not know this. So let's take out our calculator and say 16 divided by, just kidding, 32 divided by 16. And look at that. It does. It divides evenly because this is not a decimal. So 16 times 2. So the square root of 32 equals the square root of 16 times 2. And then I break that into two separate square roots. Square root of 16 times the square root of 2. Well, I know that the square root of 16 is 4, and the square root of 2 is just the square root of 2. So my final answer is the square root of 2, is 4 times the square root of 2, as we know from above up here. Okay? And that's how they got their answer down here. All right? So I looked for the largest perfect square that divides evenly into the number under the radical. So let's look at letter B. Okay? Now, notice that there is a negative sign out front. All that means is that when I do this problem, I'm just going to bring the negative along for the ride. So I say negative. Now, I have a 63. Which one of these numbers divides evenly into 63? I hope you said 9. So this equals the square root of 9 times 7, right? So I break that up. Remember, we're bringing that negative along for the ride. This is negative 3 times the square root of 7. Notice when I have the 3 and the 7 next to each other, I no longer need the multiplication symbol. However, if you feel like you want it there, you can put it there. It does not matter. But this is my answer. Negative 3 times the square root of 7. The next one, 125. So I'm looking at this. Which one of these numbers goes evenly into 125? Not 100, definitely not any of these. We're looking at 25. So I say this equals the square root of 25 times 5 equals 5 times the square root of 5. Now notice I skipped the middle step, okay? I skipped the step where I have to break that into two pieces. So here is a general rule. If you can skip this step and do it inside your mind, go ahead and do that, and you can go right here, from here to here. If you need to write this step down because you need a visual so you can see it, then that's fine, and you can have these three pieces right here, okay? So it's up to you. If you feel like you need to do all three of these pieces, that's fine. If you feel like you can go right from here to here, that's fine as well. I like to write everything down, so for people who need to see everything because they're visual learners, to each his own, okay? Now, down here, take a minute, do it on your own, come back for the answer. So here's a quick little check for you, and this might save your whole life, okay? So you can put this in your calculator to check. Let's say you're chugging along and you got all these answers and you're like feeling very confident, but you don't know, right? How do you know if your answer is right? This is how you know. You take your handy dandy calculator and then you go second square root and 24. I know the square root of 24 is 4.89897, so on and so forth. And then I got 2 times the square root of 6 for my answer. So I say 2 times the square root of 6, and I hit enter, and I got 4.89897, and so on. So guess what? I know that I got the correct answer because these two different problems ended with the same result. So there's a little cheat for you, I suppose. If you want to check, put it in the calculator so you can check your answer. So then you know, oh, I got it right. Yay, go me, right? So there's a little check for you. All right, cheers.